Hello everyone, this is my video for Vectors 2. At the start of this, I just put on some examples of how vectors are used to help us solve mathematics, engineering and physics problems. In this one, it does tell you what the forces are on an aeroplane. It's from NASA again. And this tells you why a car will get faster or accelerate. If the force U is bigger than the air resistance force B times V, the car will accelerate forwards. But if B times B is bigger, a longer line, then the car will accelerate left or slow down going that way. The same is true with the parachute. If the weight is equal to the air resistance, it stops getting faster. And you can increase the air resistance by having a bigger parachute, which means you'll fall slower. If you had no parachute at all, the air resistance would be very little and you'd hit the ground very hard. Here's another one when you're balancing a ruler on your finger maybe. This little triangle is called a pivot, and you can get forces, one from the weight of the ruler and one from the string holding the ruler up. And you could calculate how much tension, how much pull that string needs to have to stop the ruler from falling. And when things are going around in a circle, the velocity vector is always 90 degrees to the radius. But there's always a force towards the middle of the circle. Like if you imagine swinging your arms around, you can feel the pull on your arms just by keeping your hands moving around in a circle. And if you have a pendulum which goes backwards and forwards, the weight is always down. Weight is always down everywhere, but the tension or the pull from the string changes its angle as the pendulum moves. Right, but in maths class, they're just lines with arrows on them, and that's about all there is to it. Right, this is what it says on your Pearson exam paper, Edexcel exam paper. We've got to describe translations as 2D vectors. We kind of did that a little bit before, but I don't want to do that bit today. I'm just going to do the addition today. Usually I do both addition and subtraction, but I'm only going to do addition today. Right, 3 ways to write vectors. We can write them like that, or we can draw a picture of it. See the arrow is going from A to B. So look at it, it's 1, 2, 3 going right and 2 going up. 3 going right, 2 going up. So these are all exactly the same. Right, now if you have 3 dimensions, like an X, Y, or Z, and Z, or an I, J, and K, then we must use the right hand. And the red line will follow the first finger. The thumb goes up following the blue line, and the green line into the screen is the second finger. So I, J, and K, try and remember with your fingers. Okay, adding the vectors. It simply means this. It means moving. So if this is A and this is B, if you want to add them, we just move B. So it's on the end of A, and A plus B, which I can't write A plus B in GeoGebra, but A plus B is U on this one. So the new vector, which is called the resultant of adding A and B together, is just the vector from the start of A to the end of B. That's if you're doing it by drawing a picture. But if you're not, you just add the I numbers, or X numbers. 1 and 3 gets 4, minus 3 and 2 is minus 1. We could write it like this as well. So 1 plus 3 is 4, minus 3 plus 2 is minus 1. So we get the same answer in all cases. So this is 4 minus 1. We can check that on the picture. 1, 2, 3, 4. And he's going down 1, so that's minus 1. Okay, that took a long time. Now I've given you some questions here, which is not going to stress you out too much, I think. These ones you're going to have to type it into CodeCogs, which is this. We used that before. But I've given you at the very bottom of this, I've given you the code, and I've given you the link to CodeCogs. I've given you the GeoGebra when you have to draw a picture, like these ones you have to draw a picture. These two are in 3 dimensions, and I did not give you the code for that. I'm hoping that 1 or 2 of you will still have enough energy to try and work out how to change that code so that you can have 3 dimensions. Well, I'll give you a bit of a clue now. If I go down and I type in 6, like that, now I can have I, j, and k in CodeCogs. Actually, I'll show you that in CodeCogs. Right, so that's my vector there. If I go to here and I push this unusual slash going the other way, and then another one, I can get it in 3 dimensions like that. Okay, so that's the challenge part, but it's not that much of a challenge, as you can see. Okay, guys, if you still don't get it at the end of all of that, there's a Khan Academy Vectors video that you can watch instead of mine. See you in class, guys. Bye-bye.